Hello, this video is going to look at finding the derivatives of your trig functions. Before we looked at sine and cosine, and here we're going to look at the tangent, secant, cotangent, and cosecant functions. And once again, just like the sine and cosine functions, these you just have to basically memorize. For example, the derivative of the tangent of x is simply secant squared x. The derivative of cotangent is negative cosecant squared x. And the derivative of secant is secant x tangent x. And the derivative of cosecant x is a negative cosecant x cotangent x. Now, I do want to start off looking at an example here, y equals the tangent of x. And you could do this similarly for the secant, cotangent, and cosecant, but I'm just going to look at this with the tangent function. Now, we know based on the definition up here for the derivative, we know the derivative of tangent is simply secant squared. Well, I want to actually kind of prove this by rewriting this tangent function. Well, we know the tangent is the same as sine x over cosine x. Well, if we rewrite this in terms of sine and cosine, we now have division, and if we want to take the derivative, we can use the quotient rule. And we already know the derivative of sine and cosine, so once again, if we think of this as u over v, and we take the derivative, we would have the bottom function cosine x multiplied by the derivative of the top, and the derivative of sine x is cosine x minus the top function sine x multiplied by the derivative of the bottom function and the derivative of cosine x, and be careful, this is a negative sine x, all divided by the denominator squared. So this would be cosine squared x. Now realize, kind of want to review this now that we have this is cosine squared x on the bottom. What you need to recall, I know some people tend to have problems with this, recall that if you have cosine squared x, this is the same thing as writing parentheses cosine x, the whole function squared. Now, keep in mind, this is a shorthand notation so that we don't have to include the parentheses. So when you see this cosine squared x, that really means you're squaring the whole trig function cosine of x. Now, for example, if you were to write cosine x squared, in this case, only the x is being squared, not the entire trig function. Okay, so be very careful with this. So here, this cosine squared x means the whole denominator is being squared. So once again, here's the derivative, and from this point, all we're going to do is simplify the expression. Cosine x, we could certainly write that as cosine squared x. And we have two negatives multiplied, so a negative and negative makes this a positive sine squared x all over cosine squared x. Now be careful. I know at first glance you're thinking, oh, well, we can cancel out the cosine functions, and we can do that. That's one way to do this. Another way is you could say, well, if we look at this, we could take what? Cosine squared and plus sine squared. If you have cosine squared x plus sine squared x, remember this is one of your Pythagorean identities. So in this case, we could rewrite this as 1 over cosine squared x and 1 over cosine squared x. Remember, that is the same thing as secant squared. So we could rewrite this simply as secant squared x, and this here is the derivative of our tangent function, and that's what we have up here. Tangent of x equals secant squared x. And again, you could go through a similar derivative for secant. You could write this in terms of cosine. Same thing for cotangent. We could write this in terms of sine and cosine, and we could come up with the derivative. But if you just simply remember, tangent is secant squared, secant is secant tangent, cotangent is negative cosecant squared, and cosecant is negative cosecant cotangent. So once again, here's an example, y equals x squared secant x. And if you want to try to pause the video and work this out on your own, and then you could play the video to see if you got it correct. Y equals x squared secant x, the first thing you need to realize is that this is actually the product rule. Okay, so here you're going to have to use your product rule because we're multiplying x squared and secant x. So the product rule says we're going to take the first piece and multiply that by the derivative of the second, and the derivative of secant, well, we just learned that is secant x tangent x plus your second function, which is secant x, multiplied by the derivative of the first, which is 2x. And then at this point, all we're going to do is simplify. And again, in this case, we can rewrite without parentheses. So we simply have x squared secant x tangent x. And the 2x, we're going to write the 2x in front to get 2x secant x. And at this point, can you see any way we could simplify this any further? Well, if you notice here, we have an x squared and an x, so we could certainly factor out an x. And we also have, so here I have an x and an x. We have a secant x and a secant x. So we're able to factor out a x secant x. And if we take out one of the x's, we're left with the x and the tangent of x. Plus, if we take out the x secant x here, we're just left with the plus 2. So here we have the derivative x secant x times x tangent x plus 2. So once again, keep in mind when you're looking at using the derivatives of these trig functions, you still have to keep in mind all of the other rules we've talked about up to this point, which as far as the constant multiple rule, and specifically the product rule and the quotient rule. So if you have a trig function, just like we do here, that's being multiplied, in this case we had to use the product rule. So keep in mind of all the other rules that we've talked about. So once again, find the derivative of tangent, secant, cotangent, and cosecant. These are just 4 derivatives that you will simply have to memorize.